Okay, so the following graph shows a Riemann sum. Okay, now what we're supposed to do is we're supposed to write this Riemann sum in summation notation. So I'm going to try to make this really simple, okay? When we find areas of rectangles, which is what we're having right here, we have a bunch of these rectangles, right? When we find areas of these rectangles, all you're doing is you're finding the height and you're multiplying it times the base, right? And then you have to, add and you keep going, all right? You have to keep doing it for each of them. Now, instead of saying height, we're going to say the value of the function. So the value of the function times, now instead of the base, I'm going to say delta x, okay? So the question is, how do we find this delta x? And how do we find the x inside the f? And actually, I'm going to change that x to be x sub I, all right? So let's start with delta x because I think that part's a little easier. Okay, now most of you guys can probably figure out delta x just by looking at the graph. But we have to know how to find delta x other ways just in case the graph is not an easy way to do it. So here's an easy way to do it if you practice at it. Okay, this is how you find delta x. First, you need to know the interval, like where you begin and where you end. So the interval is right here. So we're beginning at 0 and we're ending at 2. So usually what all you have to do is go 2 minus 0. So you go the upper bound minus the lower bound, and that's how you get your interval. Now this one's kind of obvious. It's just 2. All right, easy peasy. And then you divide that by however many rectangles or subdivisions the Riemann sum is 4. Now this Riemann sum says 6 equal subdivisions, so we're going to divide this by 6 and we get 1/3. And some of you all are thinking, I know what you're thinking. You're like, oh, I totally saw it, Mr. Patey, because look, from 1 to 2, there's 3. It divides it into 3, so I knew it was 1/3. Good job. Okay, but know how to do this so that if it's not that easy, you're able to just easily pump it out. Okay, so the delta x is 1/3, so let's write 1/3 right here. And now the question is, how do we find these x's inside of the f? Okay, now this is very important. We are dealing with a left Riemann sum. That means for each of these rectangles, we need the left x. So can I talk about this one right here? So this one right here, this would be the right side and this would be the left side of the Riemann sum. So do we want this x or do we want the 2? And the answer is, well, since it's left, Mr. Patey, we want the left side. We want this guy. And so check this out. That means we want this x, that's our first x, we'll call that x sub 1. Then we want this x, that's our second x, we'll call that x sub 2. That would be for the second rectangle. And it's hard to see those rectangles because they're really small. And then we have this x, that's x sub 3. We can see this rectangle. Okay, that's the left side of that rectangle. And then this x, which is 1, that's your x sub 4. Then we have x sub 5, x sub 6. So the last one is this point right here. So you see how we never use the 2? That's because it's the right side of the last rectangle that we care about. Okay, so we have 6 x's. So how do we find all these x's? Well, there is a template that you guys can use, and this is how I like to say it. X sub I equals a plus delta x I. Okay, now let me explain. Now delta x, you guys know how to find that, but why are we adding that to the a? What is the a? This is going to be our lower bound, our lower boundary in the interval. So that's going to be 0. So this is kind of working out in our favor. I mean, 0 is a nice number. And then we add delta x. Well, let's not write delta x. Let's write what delta x is. And then we add 1/3. But why is this I right here? The I is there because the question is, how many 1/3 do you want to add to get your x? Now, the very first x is 0, which is kind of obvious, right? It's right there. Okay, so how many 1/3 do we need to add to get 0? And the answer is nothing. So we don't want to add any 0. So in this case, the I equals 0. What about the second x value? Well, the second x value, you would start out with 0, and then you would add how many 1/3 to get the second x value? Let me see. 1. Oh, okay, so we would add 1. So the I would equal 1. And then for the next x value, oh, my stylus is being weird. We would go 0 plus how many 1/3s would we add to get to the third one? So let me see. 1, 2, 2. Okay, so I put a 2 right there. You see the pattern? I hope you guys see the pattern. So what are these numbers right here? They're the I. What's the I? The I is a number on the bottom of the summation that is changing every time you redo it. Okay, so if you understand summation notation, you understand that it's called iterations. It's going to this summation sign right here is going to do this when it's 0, when I is 0, when I is 1, when I is 2, and 2 is the last one, so then it would stop. Now that would be kind of bad though, because we can't just do it 1, 2, 3 times. We have 6 subdivisions, so we know right away that this one's not going to work and this one's not going to work. Why? Because it only goes to 2. All right, so the answer is going to be B or D. So we got to do a little bit more work so we can finish our job. Let's write out what x sub I equals. Okay, so let's use green again. Okay, so we have f, and what are we plugging in? We're plugging in 1/3 I. Where'd the plus 0 go? We don't need plus 0, right? Because it's 0. What is the function? Oh, the function is x to the third. So I'm going to go 1/3 I raised to the third power. Oh, okay. All right. So can we simplify that a little bit? Because I don't see actually here. Let me erase stuff over here, or I'll just move it out of the way because that'll be faster. Okay. Do we see? We know it's not those two. Do we see this here or here? I think. Wait, not here. We already said no to that. Here or here. And the answer is yes. Oh, so they don't simplify it. Oh, that's kind of cool. So we know this is going to be our answer. The answer is D. But if you did have to simplify it, let's see what it would look like. It would be 1 over, that would be 27 I to the third power times 1/3. And so that would be 1 over 81 times I to the third. And you'd probably just write it out like this. So we could have had the summation looking like this. That's supposed to be equals. Man, my stylus is being weird. Okay, so this is right and this is right. They just didn't simplify it all the way.